Okay. Your programming test number 1 will be this Friday during your enroll session. Please just make sure you attend the right section. We're gonna take attendance like last time. Your programming test 0 result and feedback have been released earlier this morning. Please check them on your e-class announcement about how to check your feedback and also marks. If you have any doubts, you can speak to me during the in-person office hour or you can submit a regrading request. I believe the due date for the regrading request will be next Thursday. You still have enough time to consider if you want to. And for your programming test 1, you got a guide, you got a practice test 1. So there will be a review session tomorrow in person. So I will confirm again using the e-class announcement, but it's going to be 4 p.m. tomorrow, Wednesday, CLH, Curtis Lecture Hall, just across the LaSalle building, and also M. And tomorrow, June 11th. Okay, hopefully see you there. Okay. And your priority now, of course, you should really look at the Lab 1 solution if necessary to study for your programming test 1. But your Lab number 2, I believe, is also due next Monday. So please make sure you complete in time. I'll give you guys solution, but you really want to struggle through the various aspects about Lab number 2 before you look at the solution. That'll be the best way to get prepared for the next programming test. And we got 2 slides completed already. I'm going to complete the JUnit testing in TDD in the first 1/3, hopefully today. And then I'll start a new lecture. And hopefully before the reading week or study week, we can cover a major portion of the equals method, which will be the new lecture. We'll see how that goes. Okay. All right, any question about the course? Right, we're kind of approaching halfway. I can give you guys a little bit of a look ahead. So after the reading week, I'm hoping to take about 1 or 2 lectures, hopefully, just to cover a little bit about, to finish off the equality, object equality, and also aggregation composition, which is quite a natural extension to aliasing, which shouldn't take us too long. And then I want to get to the major topic for this course, which is advanced OOP. So we're going to learn about inheritance. I'm going to dive very deep into inheritance, both about coding and also theoretical foundation about inheritance, which will lead you a long way, not just for Java, but also for many programming languages that support OOP, right? We're going to spend at least 6 to 7 lectures about that. And then after that, we're going to go on to recursion, which will be the next, last topic for the course. That's roughly the plan for after the reading week. Things will get a little more challenging, once we get to inheritance, because we do assume basic OOP, but I'll guide you through. But you want to keep up with the study. Hopefully you can catch up with a little bit during the reading week. Let's do a quick recap for last time. All right, so last time we spoke about different components for the test. Let me just go very quickly, right? Just about things that we went through quite a bit. So we talk about the state diagram here, just for deriving test cases. There will be certain test cases that will be testing where we are not expecting any exception to be thrown. And there will be some other category where we do expect certain exception to be thrown conceptually. And then we spoke about basically the test method versus the method under test. Right? So about these 2 kinds of methods. You can refer to the lecture recording for this part here. It's very important for you to really clarify about which is which. And we spoke about the test-driven development and also regression testing. There's something I forgot to mention about regression, right? I think you may have heard about regression before, maybe when you were doing your reading, maybe back in the elementary school. Your teacher might told you that regression, when you're doing reading, is not a good idea. Regression simply means if you got a page to read, maybe I've read several lines and then I go back about something I forgot. And then I will continue and then go for a few more lines and then I go back and to read over the passage over and over again, keep repeating myself, not being very efficient. Regression is a very bad word for reading. However, regression testing is a very good word for software engineering practice. That means we simply run the same test cases over and over again every time you introduce some changes. That's really the essence about test-driven developments, right? Something I didn't quite mention last time, but now you know. There's also a name about regression testing. You want to practice as much as possible. And we talk about the easiest way to really fail a test is by using the fail assertion, which turned out to be very useful strategically, right? About how we set up the test, whether maybe some exception is expected to be thrown versus not to be thrown, right? You got to put the fail assertion in the right place. I will recap that very quickly. But this fragment here just defines about what does it really mean when a test case in JUnits actually pass. Basically, no assertion failure and also no unexpected exception. Notably, null pointer and array index out of bound. Okay. And so these are just simple exercises for you to kind of check the different assertion. I'll leave that exercise to you. If you got any doubts about doing this exercise, you can see the solution on the slides, but you can reach out to me during the office hour. More than happy to clarify. And that one just about assert equals, but for double digits, just for a fractional number, like a decimal with a decimal point. You need some tolerance, epsilon. And we talk about the different components for test. This is very important. This page here really summarizes what you should really have in your, mentally, right? You want to kind of keep that in mind. You might be expecting some exception versus you may not be expecting some exception. Depending on what your expectation is, if some exception occur, it might pass in one case, but it might fail in the other case. So it really depends on what your expectation is, right? Just remember that. And we basically spoke about the first example there, where we are trying to just increment the value from 0 to 1, in which case we don't expect any exception to be thrown. In that case, we'll put the fail under the catch, meaning that if the exception somehow got thrown unexpectedly, we should really fail the test. Okay? If we are able to go from this method call to the next line, that means the exception did not occur. Okay? So you can look at maybe the different tracing that we spoke about here. Another very important message for you guys to remember. The true value about any test you're talking about is not only to just show you pass when you are given something that's correct, but also it should really show you fail when something passed under test is actually incorrect, right? So it should really give you both possibility. It should be a good filter, like a good guard to really show to you whether something goes right or wrong. Right, so we talk about correct implementation versus incorrect implementation. So you guys can maybe look at the tracing that I did from last time. The second example we did was kind of the flip side about the story. So here, in this case, since we are trying to decrement when the counter value is already the minimum, so what we do expect to happen is some exception to be thrown. In that case, we should put a fail assertion in a different place. Right? You should really review the logic about why we should put the fail here as opposed to in the catch block. Right? So guys, don't forget, you actually got your written test number 1 after the reading week. So when you actually study for your written test number 1 during the study week, you really want to somehow get these kind of logic straight. I'll give you guys some practice question, maybe when the reading week starts, so you can take a look. All right, so correct versus incorrect implementation, right? You can look at the tracing for each. And the last example that we spoke about is somehow we got some mixed expectation. For phase number 1, over here, we do not expect any exception to occur. But in phase number 2, in the same test, we do expect some exception to occur. It's definitely valid. In this way, you have to look at the fail is put over here in phase number 1, but fail is put over here in phase number 2. You want to see exactly how this is actually placed logically. All right, I'll leave the detailed study to you. And we went over just one example about given the correct implementation. I promise I'm going to do another 2 with you. Let's do it. It's good review anyway. Okay. Any question from last Thursday? Okay, let's do 2 more examples, in this category, just to complete it. All right, so what I would do is I still have this mixed expectation. All right, let's now try to trace it very quickly. So I'm going to make the implementation wrong. So what I would do is I'm going to change this equal here to less than. It's going to make it wrong. However, let's see exactly how it's going to be caught by our test case, by failing the test. Let's see exactly how. All right. Oh, sorry. There we go. All right, let's now try to trace it. So what we do is, let's now start with this line here. And if you remember, let's recall, C dot value is going to be initially just 0, the minimum value. And then we're going to go into the try block over here. And then we're going to increment basically 3 times, right? Let's now take a look what's going to happen. When I try to execute the very first method call, which will be C dot increments, and then let's now step into it, right? And we're going to call this method here for the very first time. So this will be number 4. Right? For number 4 here, the value for the counter is basically 0 here. And we know that the maximum value is a constant. It's actually 3. 0 less than 3 is true. That means we're actually going to throw this exception. So this will be number 5. So this exception here is thrown unexpectedly. Right? Agree? So now we want to go for number 6. Where should number 6 be in this line here? Line number 7, it should be caught, right? So somehow this value to large exception is going to match the value to exception here. It's going to be caught. So we're going to get you can think about the rest of the try block is going to be bypassed. So we get number 6 over here. So we're going to get caught this exception here. That's unexpected. So that's why you got number 7 here. You failed it. It is also very important for you to know this. As soon as you execute a fail assertion, the rest of the test case is going to be bypassed. You don't really continue with the execution. This is very important understanding for doing some exercise that we're going to do a little bit later. All right? So just remember here, the rest of the catch block is going to be bypassed. And this part here is also going to be bypassed. Okay? I'll make a note for you. You want to think about as soon as we actually got the fail assertion executed, as soon as the fail assertion is executed, the rest of the test method is bypassed. Because the test will just fail immediately. It fails immediately. All right, it's a very important insight for you to know. Immediately. Okay? All right, any question about this one here? We good? This is one possibility of something going wrong. Because in phase number 1, we don't expect any exception to be occur. Somehow it occurred unexpectedly. Let's say we try another kind of a wrong implementation. Let's say nothing went wrong in phase number 1, but somehow something went wrong in phase number 2. Right? Just want to give you another example. Right? Let's try another possibility here for incorrect implementation. So now here, rather than, we used to do less than, right? Why don't we do larger than? Just to play with the logic a little bit. So I'm going to put larger than over here. All right. What this tells me is I'm only going to throw the new value to large exception when the value is strictly larger than counter that max value. That's what I'm going to do. All right. Okay, let's give it a try again. So this implementation obviously is kind of wrong logically, but we're going to see how the same test is going to fail at a different point. Let's give it a try. So we got one here, and then that one there is going to give us C dot value would just be 0. And then we go into the try block right here, right? So now let me speed up a little bit. Of course, you can step into each of the increments. You can actually try to see, for example, let's say for this very first increments, the counter value is going to be 0. 0 larger than 3 is false. So the exception will not be thrown, which is good. All right? So this is going to be the case for all the increments. You can verify this by yourself. So let me just speed up things a little bit. So what I would do is I'm just going to have number 3 here, number 4 here, and number 5 over here. Number 3, after that, C dot value is going to be incremented to 1. For number 4, C dot value is going to be incremented to 2. And for number 5, C dot value at the end is going to be incremented to 3, just reaching the maximum. If you do another increment in phase number 2, you should expect some exception to be thrown, value too large exception. Okay, we'll see. So now we are at the end of the try block. So we totally bypass the catch block. All right. And then what we do is, let me just do a little bit better because we do have a line after that. So this will be bypassed, and then line now 6 would be line number 10 right here. So this will be outside the catch block, right? We're going to execute everything outside the catch block. So now we know that the c.get value is exactly equal to 3, as I just mentioned, and the maximum value is also 3. That's expected. So this assert equals here pass, which is good. Let's now reach phase 2. So I'm going to go for 7 here, another try block, and then I will go for number 8, right? So let's now step into to see how this wrong implementation can cause some failure. Now let's step into. And then we got, at this point, c.value should be 3. So this one should be 3. Now, 3 larger than the maximum value, which is 3. 3 larger than 3, false. Which means we still bypass. So let me just put number 9 here. We are checking the condition, but we bypass the throw over here. So we're going to go for number 10, which is going to execute the else part. And that one there is actually going to increment the value from 3 to 4. Obviously, this is wrong. You should never let a counter value go above its maximum, which is 3. All right? So now that's number 10. And then we are now at the end of the increment. So now where should 11 be? 13? Agree? Yeah. Because there's no exception thrown, we are just going to go to the next line after 8, which will be 11. So this part over here is actually going to fail the test right away. Oh, let me use a different color. It's going to fail the test right away, right here. That's 11. And then we're going to bypass everything else, right? Bypass. And if you want, you can think about if there's any more lines after outside the second catch block, you may have 12 over here. If there's any more line for you to execute, okay? So if you compare these two incorrect implementation, one is going to fail right here. Okay, let me just highlight it. One is going to fail right here for the version number 1, and the other one is going to fail in the second phase. You know, we are failing for different reasons. So that's also something you want to make sure you really grasp very accurately. All right, any questions about this one here? All good? Okay. Okay, let's now do some exercises. I just got 3 more examples to discuss with you, and then we're done with the JUnit test cases, like a TDD. It's quite a nice little lecture there just to review some stuff and also apply exceptions and also fail assertion. Okay, let me remind you guys. So slide number 32. So this is the 2 try and catch block that we just spoke about, right, with a different test input. Let's now keep this one in mind. Especially, you want to really pay attention to where the fail assertion is put in for phase number 1 and where the fail assertion is put for phase number 2. Let's now have some exercise to think about together. Okay, exercise number 1. This one here. Okay. So this one here, I'm trying to somehow mimic the structure for this guy over here. I'm trying to. Basically almost the same, except rather than having fail, I'm just going to say system.out.println error. Let's say. If I do that, what's going to happen? So basically you can see here, I simply say println error rather than fail. And also here, I simply say println error rather than fail. Okay, let me just switch to iPad and then let's discuss this one here. Okay, this one here. So you can see we got 2 possible error messages. One will be right here. And the other one is right here. So you can think about when we go from this example here, where we use the fail, and we use the fail right here. We're just replacing the 2 occurrences of fail by printing out error. That's what we're doing. Oh, I beg your pardon. I highlighted the wrong thing here. I really meant to do it here. Okay, these are the 2 places. So now the question is, if you compare this version here versus the other version where we got fail assertion, are they kind of equivalent in terms of the execution path? Most likely they are not equivalent. Otherwise, why would we bother to study that, right? Most likely. But let's see exactly how they're different. Okay, little bit hints for you. Okay. So think about here. In phase number 1, we do not expect any exception to be thrown from either this or this or this. Specifically, we don't expect any value too large exception to be thrown. Let's say, hypothetically, what if a value too large exception is thrown unexpectedly? Think about it just for a few seconds over here. What's going to happen, right? You should really think about what's going to be the execution path. If you compare this versus if you got fail, are they going to be the same or different? I kind of gave you guys some hints just a few minutes ago. I'm not sure if you caught that, but that's okay. Okay, thinking this way. The execution path is going to go like this. Let me say, for example, this is number 1. That's where I execute this method call. Let's say somehow this exception was thrown unexpectedly. Where should 2 be? 9, right? And then 3 will be, I print out some error. In the case of fail, we said that will be the last label. Because fail, that means you're going to fail the test right away without executing anything further. But what about printing message here? Are they going to be any 4, 5, 6, etc.? There might be. For example, after this, we are now at the end of the catch block. We might still do number 4 here and number 5 here and etc. That's really some difference over here. Okay? And that one there is inappropriate. Because, for example, let's say also assume. Let's say the increments 4th call throws the value too large exception. Let's say, I'm just trying to create one scenario for you. Let's say this one here is going to throw the value too large exception. That means we're going to bypass over here, and then we're just going to catch it. And then this will be number 6, and this will be number 7. If you think about what's really happening here, at the end, what kind of input are we going to, what kind of printout are we going to get? We're going to get this printout first, error, this, and success, this, both to the console. We're creating some inconsistency. We'll be confused, right? So the take-home message for this example here is the fail assertion is going to fail the test right away without continuing with the normal execution flow. But if you only do print line error here, it will not be satisfactory because you still continue with the execution flow, in which case you might print out contradictory messages. Okay? That's exercise number 1. I'm just going over the answer with you right away, but you can think about it. Okay? All right, exercise number 2. Okay, this one is also interesting, all right? Basically here, what I'm doing is, I'll show you exactly what I did, okay? It'll be easier for me to do that visually. If you look at this version here, right, of the test, let's say I don't quite like having 2 try and catch block. What I would do is, I simply say, I want to get rid of the second try and catch block. I simply move the C dot increment over here into right here. Let's say that's what I want to do. Okay? Make it cleaner. That's what I have. So I got phase number 1. I got phase number 2, right? Let me just remind you very quickly. So I got over here phase number 1. And I got over here phase number 2. And you don't want to forget for phase number 1, the value too large exception not expected. Versus when we talk about phase number 2, the value too large exception would be expected. Now, is this new test appropriate? This is like a typical written test or exam question I like to ask. I might just give you a fragment of tests, and then you want to justify whether or not it's a good design or appropriate design for the test. Okay, well, anybody will want to try. If you don't think that's appropriate, why would it not appropriate? Yes?
Maybe you should have a fail at line 9 before implementing again.
You mean like over here? You mean here? Just above. You mean like here?
Yeah.
Why would you do that?
Well, I guess because I have the assert equals.
Assert equal itself is actually going to fail if you don't really have the matching value. That's not exactly the way to go. Yeah, but good try. Yeah, I'll take one more. Go ahead.
Fail should be under the catch because if the exception occurs, then we have to catch the exception.
Indeed. So that's why we got, let's say here. Let's say we got value to large exception, right? Let's focus on this one only. Let's say the only possible exception that might occur is value to large exception. And we do have it here. So we don't need another catch block. But somehow this test here, I can tell you is not appropriate. Okay, let's look at some hints quickly. Okay, let's follow the hints a little bit. Okay, so I talk about line number 12. Okay, so let's say say line number 12 is executed right here. Let's say we're thinking backwards basically. Let's say if somehow for the execution flow, we actually go to line number 12. What does that mean? That means some value to large exception was thrown. But now, should we pass or fail? If the catch is done here, so now we are having a critical decision right here, right? In the body of the catch block. Now the question is, should we pass or fail? Pass or fail? Should we pass? Should we actually fail because phase number 1 doesn't expect any value to large exception? Or should we also fail because it does, should we also pass because that one is really expected? There's no option to pass and fail at the same time, of course. Now, question is, should we pass or fail? The answer is we don't know. We don't even know where that exception came from, right? So if we got some value to large exception, it might come from one of these methods, in which case we should fail. Or this value to large exception may come from this increment, in which case we should pass. Now the problem is, either we pass or fail, we cannot do it at the same time. So that's why the original two try and catch blocks are the only way to design the test. You should not try to mix them in a single try and catch block. Okay, I'll write it down. All right, guys, it's very important actually exercise over here for you to see. All right, pass or fail. So here, you want to say something like, okay, right here. If the value to large exception is actually from phase number 1. From phase number 1, right? This is phase number 1. That means we should really fail because it is not expected. On the other hand, if the value to large exception is actually from phase number 2, which is right here, that one there we do expect the exception to be occur. In that way, that should really pass. And the problem is we cannot really fail and pass at the same time. So that tells us the current test is not strong enough to distinguish between the two phases. All right? All right, so that means try and catch blocks. We need 2 of them needed to distinguish between the two phases. All right? All right, any question about this? This one is interesting, right? You got to think very logically about when you have different phases in your code, and then each phase got different expectation, then you should really separate them in different try and catch block and set up the fail assertion differently. All right, that's the main message. All right, so there's one more example I would like to talk about. That one is not really exercise, just to show you some example about. If you are kind of interested writing some JUnit test case yourself, you can somehow use a for loop to somehow test many things in a single test. That's something I want to show to you very quickly. All right. So can you guys please take a look at this fragment of code just for 1 minute? Try to see what it is trying to do. And of course, you can see that this one here is a test, right? You can see we got a test tag over here, and then we have a test method here. Try to see what it is trying to do. And then I'll explain that, and we're done with this lecture. And then we'll move on to a new lecture. Okay, just helping you a little bit. And notice that there's only one try and catch block. Try, catch, and catch. All right. Okay, just take one more moment just to see what the test is trying to do, and then I'll explain that. It's quite a nice way to really test multiple values in a single test. But usually in the starter test you're given, we don't typically do that. But I think if you're kind of interested in doing that for yourself, when you're testing your solution for the lab, you can feel free to practice. Okay. All right, let's now take a look. Okay. So what we're really trying to do here, if you remember the state diagram, let's now redraw that very quickly, right? If you remember, we got some start state. We got either counted value can be 0, can be 1, can be 2, can be 3, right? So these are the 4 possible values. And we can either go for increments, and also increments. So you can see we can only do maximum 1, 2, and 3 increments. So that's exactly the first for loop is trying to patternize over here, all right? You can see that what we're trying to do here is I would be the minimum value to begin with, which would be 0. And then it's going to be strictly less than the maximum value, 3. So that means I is going to be 0, 1, and 2, right? These are going to be the values in the iteration. We're going to execute this for loop 3 times. The first iteration, we're going to test for this. Second iteration, test for this. Third iteration, test for this. That's what we're doing, okay? Let's see exactly. So we initialize the I to be this value here, and then we say the current value, for example, I'll just do the first iteration here. The current value will just be 0 for the very first iteration. And then we're going to execute the increment method if anything that went wrong unexpectedly. Either value too large or value too small exception occur, we're just going to fail the test right away, right? That tells us if anything unexpected happened, we failed the test. And then increment should really go from 0 to 1, right? So that'll be the counter value. So C the get value should be 1, as opposed to the current value, which stay the same, 0 and then plus 1, right? So this one should really match. If you go for the second iteration, you're going to make sure once you have incremented from 1 to 2, it's also going to match the value, right? And etc. It's going to be 3 iterations. And so the first for loop is basically just doing this, okay? The first for loop is doing exactly these 3 increments. And correspondingly, we also got 3 decrements. Decrements, and also decrements here. So that will be basically the second for loop right here. And it's going to be done in a very similar way. That means over the course of the for loop over here for 3 iterations, we're going to decrement, and decrement. If anything unexpected happened, we're also going to fail the test. Otherwise, you're going to make sure assert equals the value has been decremented, right? Done in a very similar way. If I did not have any of the for loop over here, I will have to separate them into 1, 2, 3, 4, 5, and 6 different test cases. Whether you want to go for 6 separate test cases or a single one, it's kind of up to you. But I just want to show you some possibility. You can feel free to somehow automate or patternize about similar assertions you have to write. You don't really, well, imagine that if I got minimum being 0 and maximum being 1,000, then for loop might be very appealing to you, right? I'll make a final remark. So the for loop over here will be very, very useful if you got a very large range. Okay. Right here and right here. Okay, it will be useful when the range between the minimum value and the maximum value is large. In which case, you can just patternize about the assertions using different for loops. Okay. All right. Any questions about this? Yes.
For the assertion rules for both cases,
Yep.
we do +1 and -1 to match the value each time.
Yeah, exactly. Yeah. So you can think about, well, when you study the tracing, you can see that every time we simply see what's the current value before we do the decrements. So we got to make sure after the decrements, the value is going to be before the decrement -1. Yeah, that's what we're doing. All right, if no further question, that's basically the end of this particular lecture about G-unit testing, right? And that's something we just spoke about. And there are certain test cases over here for you guys to really consider, right? Do the practice. If you want to go over your solution, feel free to reach out to me. And I spoke about something about error injection. If you got a green bar at the moment for your software projects, you can try to inject some error to make sure you get a red bar. That's also one way to make sure everything still kind of work as expected. All right, some resources about JUnit 4. You can feel free to take a look if you want to. All right, that'll be it. Okay, good. Why don't we take a very short break by taking attendance, and then we'll do the new lecture after the break. Okay. So we are now done with the JUnit lecture. Okay, please review the slides during the study week. I will also confirm about the coverage of your written test number 1, which will be after the reading week. So whatever I can cover up to for Thursday before the reading week, it will be covering your written test 1. But I'll confirm. I still don't know how far I can go to. But you guys can always slow me down if you need to. All right, so let's now start with a new lecture about object equality. Okay, so this year I make a little bit improvement about the lecture by talking about something called call by value first, because when you actually want to talk about object equality, you have to somehow implement the equals method. But to really understand how the equals method should be implemented, you have to understand something about parameter versus argument. That's kind of a strengthen our understanding that we spoke before. But I'll get to it a little bit. We'll see how that goes. The slides is already on the lecture side. You can also download it if you need to. Right, we're gonna first of all, today we're gonna lay the foundation for the equals method, call by value. I'll speak about it. And by the way, you might, for those of you who may be taking or have taken 2031 in the C, you may have heard about another term called call by reference. Don't really get confused, right? When we talk about call by value, it's something to do with OOP rather than call by reference, which is more like a C language where you got some pointer, okay? Call by value, and then we'll talk about object equality. Before we talk about exception, it's either to handle or not to handle at this current caller. Equals method, in some way, also you have a binary choice. In your particular class, do you actually want to override or redefine the equals method, or you don't want to redefine? It's a binary choice again. We're going to get to it a little bit later. Hopefully a little bit today, if not, definitely Thursday. And then we're going to talk about some JUnit assertion for object equality, okay? And then that might be something we're going to review as well about short circuit evaluation, okay? And then we got equality, that's just more example about how you can implement the equals method over some actual classes. We'll see. All right. Let me now start with call by value, right? Let's now go over some example to see exactly what they really are. Okay, so let me just, okay, that's fine. You can go over the slides, but let me just talk about it on my iPad right away. Basically, call by value should be something you want to think to yourself whenever you see a method call. All right, call by. It's like every time you see a method call, so far you should think about who's the caller and who's the callee. Now the new thing you want to learn about is whenever you see a method call, you want to think about how does call by value work exactly behind the scene. Right, that's something we're going to focus on. Okay, let's now move on to here. Okay, call by value. Okay, oh, sorry. I beg your pardon, I may have missed 2 pages. If you can bear with me just for a few seconds. Okay, I'll copy that very quickly. Yep, give me one moment, just copying. Okay. There we go. Yep, my apology for the delay. There we go. Let's now talk about these 2 classes. Again, it's a bit symbolic, but we can see very clearly about how to understand the structure for call by value. So you guys know pretty well about callee and caller. Well, we can review that concept as well. Okay, let's say this. Let's say we have a method call right here, right? So let's review very quickly. Since we are trying to call this method here under this context, so we got class B, we got method N over here. So we know that the caller is beta-N. The caller is beta-N right here. And then we have a method, the callee is right here, the M that's being called. So this is the callee A.M, right? You can see that's CO, context object is declared to be A, right? So that's why the callee is A.M, right? Nothing new. And then we also got some argument value over here, right? That's also what we did in the review lecture, right? So this will be the concrete value you actually use to make the call. Okay? So the argument here is the concrete value, or just say value. So this is the value that's used to call the callee's method. Right, so that's a caller callee. But let's look at class A as well. Okay. If you look at class A, so we have parameter, I just call it param, just make it very explicit. You can think about this part over here, it's about the decoration. So this is part of the decoration. Of the caller's method. So it tells you that whenever you want to call this particular method here, you want to give a value that is of type T. That's the type, right? That's a type of the parameter. Again, nothing new. That's also something we said earlier. Okay? So now let's talk about call by value. The call by value principle is very simple in the following sense. Let me write down first and then I'll visualize it. Call by value. When making a method call, there is an implicit variable assignments. And implicit variable assignments. And what do I really mean by implicit? That means you don't do that variable assignment yourself. That's done behind the scene. It's actually done by the Java execution runtime. You have no control over, you have no choice. It's going to be done. But now we need to know what this variable assignment is exactly. Okay? Variable assignment. What is that exactly? Okay? And that variable assignment is going to be exactly the param is assigned to the arguments. Okay, first of all, let's now, so the param is the param over here. And the arguments is the argument over here. So don't forget, the order here is very important. The variable assignment is not argument is assigned to param, but param is assigned to argument. Okay, let's now visualize this a little bit more. Okay, every time you have a method call, you should really try to do this yourself. Okay, at least I'll do that in the few examples that we're going to use. Okay, let me make it a little bit thicker. So think about this is the method we are calling, and this is the method call itself. And they are across different classes, but they don't have to, right? If you remember, caller, callee can be in the same class, right? And then what we have is we're just going to have some connection here. Okay, from here to here, there is some implicit assignment called call by value. So here we got call by value, which is the param is assigned to the arguments. So this variable assignment is done first before you actually execute the rest of this method here. All right? So think about this implicit assignment here is executed before the first line of method n, right? For method n here, before we even touch the first line over here, this implicit assignment caused by call by value is going to be executed first. If you got multiple parameters, then multiple implicit assignment is going to happen, right? So these are done by the actual code you actually write for this method here. That's about the structure for call by value. But where things might get more complicated is you want to think about what types are the parameter. For example, if the t over here happen to be integer or Boolean primitive, it's kind of easier because this implicit assignment here, you're just copying the value. That's why it's called call by value. On the other hand, what if the param and argument are references? In which case, we're going to have aliasing, but we're still copying value. What value are we copying? Addresses. Okay? So we're going to see different examples here. You just got to remember, number one, whenever you have a method call, think about where this method is declared, and then there's a connection between the two, call by value, implicit assignment. Number two, how exactly the call by value is going to work depends on what's the type of the parameter and the arguments. If they are primitive, they're going to work one way, but if they are reference type, aliasing might have to come into play that we're going to see. Okay? Okay so far? Okay. Let's now see example here. Okay. Let's say we got two classes here. I'll try to make it as simple as possible, just as first example. Let's say we got the callee over here. We got circle, we got set radius. And the caller is circle user, and also let's say within the main method, let's say. And then we got this method call here, right? So let's think about call by value, right? Let's now visualize that right away. So what you will do is you're going to highlight this method call here. And then the definition for the method that being called is right here. And they will be connected by call by value somehow. So I'm just going to box this method here, and also box the call to this method here. and they are somehow connected by some implicit assignment called call by value. So the call by value here, should it be R is assigned to arc, or arc is assigned to R? The order is really important. This R here is a parameter. So it should be R is assigned to the arguments. Okay, so hopefully before Thursday's lecture, you're at least very clear about the order, about the implicit assignments for call by value. All right? Having this in mind, let's now try to trace the code and see what's going to happen. Okay? So let's say there's a main method here for circle user. So we're going to trace line by line. So let me start with this one here. So this one here is just going to create a circle objects C. So C is pointing to a circle object right here. And we assume that the circle class has only one attribute called radius. Let me call it R. And then initially, let's say the value would just be 0, right? Let's say just default constructor. And then we got some argument value here. That value there is, let me just draw a box for primitive value here. Its arguments, you can see 10, right? That's a setup. And let's now step into this method call, right? This method call here, of course, is going to execute this method. But remember, before line number 1 of this method of the callee, we have to execute the implicit assignment for the call by value. So what's going to happen is we're going to execute this assignment. So think about this. Oh, let's think about the order. How about that? So we got 1 here, we got 2 here, we got 3 here, we got 4 here, and we got 5 here. So just 4 here is kind of implicit. You don't really see that in the actual eclipse, but conceptually it's okay to think that way. Right, after number 4, you're basically just going to create that R. Oh, sorry. You're just going to create that R variable here. And it's primitive, right? Just integer, right? You can see that's integer, primitive, copy over. We got 10. All right? And then after that, you say this radius will just be R. After the call by value, you're going to say this radius will be R. So it's referring to R value, right? So this over here is basically just a context object, right? This is a context object, so that'll be C.radius will be just a copy of 10. Right? So that's what we're doing. So this is the call by value where the parameter and arguments are simply just primitive value, which is straightforward. You're basically just creating over here, the R is just a copy of the arc. Let's now try to consider another scenario. Let's say the parameter and arguments are reference types, they're addresses. Okay? Let's do something very similar. I still have the circle user class over here. I still got a circle class, I also got radius. Let's say I got another overloaded constructor, which will take the radius and then set it accordingly, let's say. Okay? Let's see what's going to happen. Okay, number 1 here, where we're going to create the C, which is a new circle. Okay, new circle here, and then the radius by default is just going to be 0, right? And then number 2, we're going to create another circle, call it arguments. And for that one there, let me just use a different color here. Let's say number 2. That one there, I'm just going to use arc. And that one there is going to point to a new object of type circle. And then you can see that I'm calling another version of the constructor 10, right? It's going to set to be 10. So the radius is going to be just 10. So after 1 and 2, I got these 2 objects here. And then I'm just going to got number 3 here. And I'm going to step into set radius. But this time I'm passing arc, right? And I'm going to step into this method here. Before I will even execute this line, what should be number 4? Call by value, right? Let's do that. So what I will do is I'm just going to highlight this part over here. That's the method declaration, and that's the actual method call. And let's visualize very quickly about a call by value. So between these two, I know that call by value is going to do C, the parameter is assigned to the arguments, right? Right? C is assigned to arguments. And this will be number 4. Okay, think about this is number 4. And what does number 4 do? That means C here. Oh, another thing for you to actually see. The C here and the C here, they somehow are different C's because they are different scope, right? So you got to be a little bit more careful, right? Think about the C here, it's more like a parameter, right? So I'll just use the C here, okay? And the C here, I'll just make blue. So you will see that they belong to different classes. They're in different namespaces, okay? Just be careful, okay? So here, the C is actually going to be a copy of arguments. So that means C is now going to point to wherever argument is pointing to. So this C here is the parameter. Okay, just be careful with that. All right? So that one is going to be done first. And then we're now going to do number 5, which will be this dot radius will be C dot radius, right? So this will be basically, so this C here is the blue one, right? That's the local variable, right? So that means that this here is going to be replaced by the C, which is referring to this one here. So C dot radius now is going to be the C, which is the parameter, which is now pointing to over here, the radius, which will be 10. Okay? So what we're doing is we are setting this, rather than 0, is now going to be 10. Let me tell you really what you're gotta watch out for. We got one local variable here called C, which I mark as blue. We also got a parameter here, which is also called C. It's in different class, so it's completely valid Java. So when you trace the code, be careful about which one. Okay. Okay, the C over here is a local variable. Local variable in circle user. Okay. If you compare these two instances of the call by value, you can see that in one case, R is simply copy the value over from the arguments. The other one, the C here is copy over the address of the arguments, right? So they're pointing to the same objects. So you can think about once you actually got this parameter pointing to the same object as arguments, you can now do something that we spoke about for aliasing. I can simply use this reference over here and modify this value if I want to. I didn't do it, but I'm going to do that in another example. Okay? So these two are just introductory examples to show to you how the call by value is going to work in some ways a consistent way, which is copying value. In the primitive case, just copy the value itself. In the reference case, you copy the address. All right? Let's now do another example, and then we're done with call by value. And call by value is very fundamental for understanding the equals method. I'm hoping to introduce a little bit today. We'll see. Okay? Oh, question. Go ahead.
C parameter, when you say that it points towards the subject,
Yep. Arguments.
does it get the address of the argument?
Yeah, exactly.
So the argument is a local variable, right?
Right.
In the second
Yeah, remember this variable assignment here is implicit, right? It's something that's not done by you. It's not done by the runtime. It's always done, even before you execute the very first line of this method here. So what it does is it's going to copy the value of this argument here, which is the address of this particular object. It's going to copy this address here to the parameter C. That means C will be pointing to the same objects.
the argument variable, right? Look, it's a local variable.
Argument is a local variable, yes.
Because there's an address pointing to the local variable. Right?
So
And
the
there's an address pointing to the new circle, right?
So the argument here is a local variable, yes. That one stores the address of this object here. So visually speaking, argument points to this object here, yes. And then when call by value happens across the two methods over here, it's going to, something implicit is going to be done. So the variable assignment C is assigned to arg is going to be done.
Okay, I think that my question though is, does C get the address of argument or does it get the address of the new circle?
C does not get the address of argument. Argument itself is an address. You don't get the address of the address. C gets a copy of the value of arguments, which is the same address of these objects. That's the way to think about it. Yeah. Question?
The call by value just points to the argument that is in the method.
Right. So call by value in the case where you got reference type, yes, the parameter will just point to the same object as being pointed to by the arguments. Yes. Yeah. We'll try to see one more example just to reaffirm this. Okay. Yeah. All right. Let's now do another example. Okay. Hopefully that one there is going to show even more explicitly about what's happening here. Okay. Let's do it again. All right. So I'm going to make the code available to you as well for this call by value here, and then you can also play with it. Okay. But let's just go over that. And let's say I got a class called utility right here. And then let's now consider just this one single method. We'll look at the other two on the other two pages, right? This first one. The first one here, you can see the parameter is actually a primitive. That's kind of the simple case for call by value. But we'll see. And then I simply say, getting the parameter, I simply increment it. This is something that you're typically discouraged to do because what you're really modifying, the j here, remember j is actually a copy of the corresponding arguments, which we'll see. So what you're really modifying here is not really the original arguments. You're really modifying the copy of the arguments. I can make a note right away. So here, we are not modifying the argument value. Instead, we are modifying a copy of it. Okay, I'll visualize it once we trace the code. I want to point it out right away. Okay, let's now try to trace the code. Right, I got one test case over here. Right, test call by value. And the first line here, we just create the utility objects. Right, we don't need to visualize it. It's not that interesting for this particular object. Okay. So what we get is we got some value I here. So here I got this. I has the value 10. And then this one's straightforward. I can simply assert true, I will be 10. So now before the method call, you can see what we're doing here. We're calling this method here with I. I want to see whether this j plus 1 is going to modify the 10 here so that it becomes 11. It turns out it doesn't. Okay, let's see exactly how. That's very important. Okay, so let's now take a look at the two method call. So we got this one here, and also we got this one here, right? These two. And let's now visualize again the call by value. So if you try to link these two, so we got the call by value. And that one there is going to do j, the parameter is assigned to the arguments, which is I. So this line here, this implicit assignment here is going to be executed before we actually do this one here, right? So again, let's now kind of label. If you think about this is number 1, this is number 2, number 3, number 4, and then number 5 here, which is implicit. And then we're going to do number 6, right? Right here. So now what's going to be number 5? Number 5 is going to be, we have the parameter j, which is going to copy over I. We got 10. Now, when we execute this line here, j is assigned to j plus 1. Are we modifying the original I here? No. We're modifying j, right? You can see j here is the left-hand side of the assignment. So we're only modifying this one here to be 11. This is why when you check this result over here, assert true, I remain to be 10, but not 11, right? It's so important. So whenever you're doing anything like this, you want to know what you're doing. If you're really thinking that I'm incrementing this value here so that this will be modified, no. You're only modifying a copy of that, okay? So here, not 11. All right. Right, so that's example 1, just about call by value in the case of primitive types. Let's now try to look at 2 different cases for primitive, for reference type. Very similar. So we assume that we actually got, oh, question? Yeah, go ahead.
If we wanted to change the I value, how would we do that?
Good question. The question was, if I really want to change this I value here inside this method, can I do it? No. In programming language like a C, yes, you can. You may have to do something like a user address operator to somehow pass the address of the integer variable. But we don't have that facility in Java. They might have it in C++, but not in Java. I don't think in C# either. Okay, but at least not in Java. Yeah. Okay. All right, let's now take a look at this one here. Okay. So now we're talking about this method here. We want to reassign the parameter over here, which is q, and we say that q is reassigned to some new reference. Let's see exactly how this is going to work. Let's see. Okay. And we assume that we actually got a point class, right, with x and y, just like before. Okay. Let's now trace the code. So we start with number 1 over here. We got utility. And also we got number 2. And then we are simply creating a new object, like a local variable. So we got p here, pointing to a point object. So this will be the point. And we got 3 and 4, x and y. So x and y, 3 and 4. Okay, right here, p. And then, just for testing purpose, we got another one here, number 3. So it's called reference before. Okay, so this one here, just copying p. So this one here, just the reference of the p before the method call. Because we know that we're going to reassign the parameter, we want to know whether we're going to reassign this reference at the same time. We want to know, right? So I'm just introducing some extra variable to help. Okay. Let's now take a look. Right, so we got number 3 here and number 4. Number 4 is the actual method call, right? So if you think about number 4 here, and also it's calling this method here. And again, we got another instance of call by value. Let's see what's going to happen here. So we got these 2 right here. What's going to be number 5? Q is assigned to P, or P is assigned to Q? Q is assigned to P, all right? So call by value. Q parameter is assigned to P, the arguments, all right? That's going to be number 5. So let me just say number 5 here. Okay, so number 5, we're going to say Q is assigned to wherever P is pointing to, right? That's before we even start executing the body of the method right here, right? That's kind of the implicit assignments. And let's now see what's number 6. Number 6 will be we are creating a new object here locally, right, within that method. So we got MP, a new point, which is pointing to right here. So that one there is going to be a new point object 6, 8. Okay, let me write it down. We got point x and y, and then we got 6 and 8. So far, so good. And Let's now take a look at this line here. Q is assigned to NP. The question is, when I say Q here is a reassign, am I going to reassign the P to be something else? No, because Q here is only a copy of the P address. So when you say Q is assigned to NP, so that one is going to be number 7. You're basically saying Q, rather than pointing to over here, is now going to point to wherever NP is pointing to. This is basically number 7. That one tells you P, the arguments remain the same. So when you do this assertion here, P is the same as the reference before. They are the same. They don't change. Okay? So what you really want to say is P here, not reassign. Not reassign. Only a copy of it, which is the Q, reassign. All right, that's a very critical point for you to note down. Not reassign for P directly, but a copy of it is actually reassigned. Okay, that's scenario number 1 for reference type parameter. We are just trying to reassign the parameter reference type into something else. That's not the way to really change the arguments. However, given that Q is really pointing to the same object as the arguments, there is something we can do to modify the argument objects. We can call some mutator on the same objects. Maybe you can modify this 3 here to be 6, for example. That's what we're going to see in the next variance. All right, the last example about call by value. Okay, last one. Yeah, question? Sorry, say it again. Where do you want to introduce?
On the test file, I create a new object, the point Q, new point, where it set is to 0, 0. So when on the pass YouTube, so I set this.
Maybe let's talk after class. That'll be easier for me to trace. And then if that's worth discussing it, maybe on Thursday I'll do that. Let's talk after class. Okay? Good. All right, guys, let me just do one more example. I think that might be good enough for today. All right, let's do it. Okay? All right, so before Thursday, please make sure you review the call by value. Very important. So when I talk about equals method, you wouldn't get lost. Okay? Let's talk about this one here, final one. Okay. So this one here, we're going to look at this one here. So you can see the Q, the parameter, we're not trying to reassign that. We just call mutator method on that. That's what we're doing. Okay, let's trace again, right? Just get complete story. So number 1 here, and then we got number 2 over here. So we got P, which is a point object here, and we got 3 and 4. So this is the point objects, and we got X and Y, 3 and 4. Similar, but let's just be patient enough to really trace it. 3 and 4, and then we got reference before. So that'd be number 3. So reference of P before. So that one there is pointing to the same objects, right? Copy of P. And then we have our method call right here, right? It's calling this method here. So this will be the call by value. Okay, number 4 is the method call. Number 5 will be the actual call by value. So think about, we actually got connected these two, right? So call by value is going to be the Q is assigned to P, right? Q is assigned to P. So this will be number 5. So Q is assigned to P. So far it's just the same as the previous one. All right, let's now step into the method called change via ref right here. Right? So if we do that, we're going to go for, so number 6 will be here, and number 7 will be here. Oh, let me use a different color, if you don't mind. So number 6 over here, and number 7 over here, right? What we're doing here is we are not really trying to reassign the Q over here to anything. Instead, we try to call 2 mutated methods here, and 3 and 4, right? So move horizontally is going to change the x value. So change this one to be 6, and move vertically, and then it's going to modify 4 to 8. Right? Exactly these two. And when we are finishing, when we are done with the method call, you can see that, first of all, P has not been changed. P still pointing to the same object right here. But if you check the value for x and y for P, you got 6 and 8. All right? Any question? All right. Before Thursday, please review about all the example we talked about for call by value, and then I'll start you fresh about equals method. Okay?